Good morning, student. Today in this class, student, I will try to explain some basics of the circular motion. Circular motion is a very important activity of our daily life, or you can say the universe. Planets are moving around the sun. The electrons are moving around the nucleus. These all are student circular motion. Fan, the blades of the fan, they are revolving. That is circular motion. So there are many such things which you can see daily, which are circular motion. Now, students, certain terms already we have learned in lower classes also about circular motion, okay, and in the previous chapters also. For example, student, when a particle is moving in a circular path, when a particle moves in circular path, student, the direction of tangent gives the direction of velocity. Anywhere, if I draw the tangent, that will give me the direction of velocity. Okay, tangent at any point, this already you know it. Tangent at any point gives the direction of velocity. Okay, student. Now, in this case, student, suppose the particle is moving with a constant speed. Constant speed. Will it mean that there is no constant speed is there? Will it mean it is a constant velocity? No, student. Not constant velocity. Velocity is not constant because its direction is changing. And since velocity is changing, so there is an acceleration. Okay, student. Now I am taking some examples, students. See, this is circular motion. Say here the velocity is 2 meters per second. Here also the velocity is 2 meters per second. Particle is moving in this way, student. Okay. How much is change in velocity, student? Is it 0? No, student. It is not 0. It is 2 minus 2. Change in velocity is 4. And suppose this is performed in 5 seconds. Then average acceleration will be delta V by delta T, student. So 4 by 5 seconds. Okay, student. Again, suppose, student, the particle, say this case. Suppose here the velocity is 2. Now here the velocity is 2. Now I want to find change in velocity from A to B. Okay, student. So how the change in velocity is given by final velocity minus initial velocity. Final velocity is in vector form, student. This is minus 2j cap minus 2I cap, student. And suppose this takes place in 5 seconds. So average acceleration will be equal to, student, delta V by delta T. 2I minus 2j upon 5. Then by vector, if I find the magnitude, I will get the magnitude of the acceleration. This already, student, you know it, this much of mathematics. Now, student, in the one dimension motion, first I am taking one example of two dimension motion. Suppose, student, the particle is moving in some way like this. Now this is the position. I will draw the position vector. So r is the distance of the point A from the origin. But the position of this is not enough by r. I have to say this angle also, student. I have to say this angle also, student. Okay. Then its position is completely defined. Now let us compare, student. the one-dimensional motion and two-dimensional motion. Suppose the particle is moving, this is 1D motion, this is two-dimensional motion. Suppose student the particle is in this line, particle is moving. This is the position of the particle. When it is at P1, the position is student. I can write it x is equal to plus 3. When this particle is here, say P2, I can write position x is equal to minus 3. Suppose this is known as linear position. Suppose this particle reaches from here to here. Now I will write, student, change in position. And change in position is displacement, linear displacement. This will be given by final position minus initial position. So 4 minus 3. This is denoted by delta x. Okay, student. Now, student, velocity. It is linear velocity, student. Okay. The rate of change of displacement. This is velocity, student. And if the velocity is changing, student, then comes linear acceleration. I can say write delta v by dt, or this is also written as in some dx by dt, student. dv by dt, as the case may be. Okay, student. Now let's compare, student, this is 2D motions. Suppose the particle is moving in a circle. This is the position of the particle. Now here there is a linear position. Here we define, student, angular position. Angular position. Theta. Pi by 3. As here the position was plus and negative also, here also, student, suppose the particle is here. This angular position will be given by minus pi by 3. Then we have, student, suppose the particle moves from here to here. And say this angle is 2 pi by 3. As there is a change in position, here there is a change in angular position, student. Change in angular position. Denoted by delta theta. Final position minus initial. Final angular position, it is 2 pi by 3 minus initial angular position, student. This is known as angular displacement, student. This is angular displacement. Similarly, we have, student, angular velocity. Which is delta theta by delta t. This can also be written as d theta by dt, and this is denoted by omega. And similarly we have angular acceleration. d omega by dt denoted by alpha. Now since these all have a unit strength, this position is meter, meter, meter per second, meter per second square. Here also student we have radian, this is also radian, this is radian per second, and this is radian per second square. Now student, when you study about one dimensional motion, the particle is moving in this way. So here student only r is changing. It does not speak anything about theta. Theta is not changing. Theta is not changing, student. But in this case, student, if you see, when the particle is moving in a circular path, this is the position. Now this particle reaches here. So in this case, if you see, student, r is not changing. But theta is changing. Here r is changing, theta is not changing. In two dimension here r is not changing, but theta is changing, student. As we have, student, three equations of motion for a constant acceleration. V is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. Similar for angular circular motion, student, we have angular velocity final is equal to angular velocity initial plus angular acceleration into time. Here, student, delta, this s is actually delta x. So this can be written as delta theta plus half alpha t square. Initial angular velocity. This can be written as, student, final angular velocity initial, and this is delta theta. A similar kind of equation also exists here also, student. Okay, student. Now, student, we are coming into a very important relationship. This is a comparison between the 1D and 2-dimensional motions. Now suppose a particle moving in a circular motion, a very small distance it is covering, say 20 s. Okay, very small, but I am showing it a very last to explain you. It reaches from here to here. Yeah. Okay, this is the angle it describes. So, student, by mathematics we have angle is equal to arc upon radius, d theta is equal to ds is the arc upon r. So we have ds is equal to r d theta. Now if I divide it by time both the sides, ds by dt it is velocity linear, and this is angular velocity. A very important relation, student, between linear and angular velocity. This is linear velocity, student. This is angular velocity. Now to clarify this formula, I will take one example, student. Okay. Suppose student I have a linear rod like this, and this rod is hinged at this, it is movable from this point, it can rotate from around this point. Now this rod after some time it is rotated from here to here, it comes here. Okay student, now I take 2 points A and here 1 point I see student B. This is following a student circular motion. Okay student, if I compare the velocity of A and B and also angular velocity of A and B. Now see student, for A the distance traveled is this much, for B the distance covered is this much in the same time. This is the linear distance they have covered. That is why student the velocity of B is higher than A. But student, if you see the angle, both of them are substituting same angle student. Angle is same student. That is why they have same angular velocity. Now see, I will save the formula, clarify. For A student, the radius is much less, so V has to be less because omega is same. And for B student, if I write this formula, radius is much high or large, omega is same, so V has to be large. So this is the difference between linear velocity and angular velocity. One more example I will quote. Suppose student, we have a circle r is equal to 1 and a particle starts from here and it covers half the circle. Okay, another circle this is radius 2 student and a particle starts from here, it covers 1/4 of the circle. This is half the circle student and the time is same. Time is same for both. In the same time, it is covering this half circle, it is covering 1/4 of the circle. Okay. Now here student, the distance covered, half the circle means 2 pi r upon 2. So this is student, r is 1, so this is pi. Now for this case, the distance covered student, quarter of the circle, 2 pi r by 4. 2 pi r is 2 upon 4. Again student, pi. So student, the distance covered is same in the same time, so velocity is same student. The linear velocity is same. But student, if I want to find the omega, now see, starting it was here, now it reaches, this is the angle it has covered. And in this case, the angle is student pi by 2. This has covered more angle student as compared to this. So angular velocity of this is greater than angular velocity of this. Though the linear velocity is same. Because it has covered more angle student. Means it will appear to be very fast. If I want to see this particle, I have to move my eyes very fast. If I want to see this particle, I have to move my eyes, rotate my eyes slowly. That is the meaning actually, the omega speed. Okay student, this is the one basic important facts. Now student, one more thing, the angular variables. Angular variables. Suppose the particle is not moving circular, but it is just arbitrary, it is moving. For example, student, this is the coordinate axis. Okay student. Now student, the velocity is along somewhere along this direction. Now this velocity can thought to have two components. This is position vector student. One is the velocity along this direction, along R, means velocity parallel to position vector, and another velocity is student of this is perpendicular to R, and this is velocity perpendicular to position vector. So this velocity student will change the value of R, it will move forward. But this velocity cannot change the value of R, it will change the angle theta student. Are you getting what I want to say? This means this a very important concept you have to remember. Velocity parallel to position vector changes R, not theta. It does not change theta, but the velocity perpendicular to position vector changes theta, not R. And student, theta is connected with angular velocity omega. Theta is connected angular velocity. This means the angular velocity, it is the velocity of the component which is perpendicular to position vector. It changes the angle, it changes the theta student. So previous, in circular motion also if you see student, see. This is the particle, this is R, this is the velocity student, see. Velocity is perpendicular to R. This velocity is changing the theta. This means the formula which we have derived student, V is equal to omega R. It is actually the velocity perpendicular component into omega R. So omega is equal to V perpendicular upon R. Means the angular velocity, the responsible factor is perpendicular component of the velocity perpendicular to position vector. This you have to remember student. This formula changes now this. Got it student what I want to say? There is a very important formula of circular motion student. Suppose student, this is a particle, its velocity is along this 10, this is the position vector r. This angle is 53 degree. So I have to find out angular velocity, student. Of this particle P. So formula is, student, V perpendicular upon R. Now student, the perpendicular component of the component which is perpendicular to R is C, student. This is one component perpendicular and this is parallel component. So how much is perpendicular component, student? You can see 10 sine 53 and 10 sine 53 is 4 by 5 is 8. So angular velocity, student, 8 upon 2, 4 radian per second. This is how, student, you have to calculate angular velocity. Okay. Suppose, student, there is a blades of the fan. It starts from rest, having an angular acceleration of constant angular acceleration of 5 pi radian per second square. Okay, student? How many revolution it will make? How many revolution it will make in 2 seconds? So let's, student, for this apply the basic formula. First I will compare with linear, then I will convert this. This is delta theta, initial velocity, half. Now, student, delta theta is unknown. This is 0, half, alpha is given 5 pi and time is given 2 square. So this, student, delta theta comes out to be 10 pi. Means angular displacement is 10 pi, student, and if you remember, student, in one round the angle described is 2 pi. Therefore 10 pi will be covered in 5 revolutions. So how many revolutions will make 5 revolutions? This is how, student, you have to tackle the numericals of this kind. Now let's solve one more numerical, student. Suppose it is given initial angular velocity to be 2 radian per second and acceleration is given to be minus. After how much time the angular velocity will become 0, that you have to find out. As you know, these two are in opposite direction, so angular velocity will reduce. After how much time omega will become 0. So student, first I am writing linear equation, then I am converting it. Final velocity to alpha delta theta. So student, this is 0, omega is given 2 square plus 2 into minus 5 delta theta. This delta theta is, student, 4 upon 10. Now, student, after this is the displacement, total displacement. Okay. From this, student, you can easily calculate time. After how much time it is going to happen. Okay. This I am giving as a homework. So, student, this is the video on the basics of the circular motion. first part. This student, you once again you study it and try to solve some problem related to this, and also try to write it on your own words. Okay, students. So thank you for today's class.